Welcome back to the deep dive. Today we're getting into something really fundamental, long-distance signal transmission.
Right.
Specifically, we're looking at the Kramer CA-HM-82. It's an 82-foot active high-speed HDMI cable.
And that length is the key, 82 feet.
It is. So our mission today is to figure out, what kind of trade-offs and tech are needed to push a full 4K signal over that kind of professional distance.
It's a fascinating problem. I mean, you're basically fighting physics. You're trying to send 18 gigabits per second through a copper wire.
Which is just a massive amount of data.
A huge amount. With a normal, a passive cable, that signal would be completely gone, just noise.
Okay, so let's unpack that. The magic word here seems to be active.
Exactly.
What does that actually mean in this context? Because not needing an external power supply sounds like a huge logistical win.
Oh, it's a total game changer for installers.
Yeah.
The active part is this advanced equalization and signal compensation hardware that's built right into the connector itself.
So it's boosting the signal as it goes.
Precisely. And the really clever part is that it just sips a tiny bit of power directly from the HDMI source. No extra wall ward, no running another power cable. It's true plug and play.
I see it also has this Kramer K-lock connector, 15 pounds of restraining force, it says.
Yeah, that's essential in a pro setup. You can't have a cable just, wiggling loose in the back of a rack.
Of course not. But that brings up a question for me. If we need active boosters and special locking connectors just to keep the signal alive, why are we still using copper? Isn't fiber optics the obvious answer here?
That's the big debate, for sure. But copper is still here because it's reliable, it's established, and it meets all the compliance standards.
Right, the safety ratings.
Exactly. This cable is UL listed, it's rated for in-wall installation, it has gold-plated connectors, triple shielding against interference. It's just a known, tough, predictable quantity.
Okay, but here's where the compromise really starts to show. Because even with all that active tech, you can't beat physics forever.
You can't. There are hard limits.
So where's that line? Where does the perfect signal start to break down?
This is the absolute key takeaway. So for shorter runs, let's say up to about 66 feet, this cable gives you the full 18 GBPs, full uncompromised 4K at 60 Hertz with 4.4.4 chroma sampling.
And 4.4.4 means every pixel gets its own unique color information, no compression.
Perfect color.
Yeah.
But once you hit the length we're talking about, 82 feet.
The spec changes.
It has to. The data rate drops to 10.2 GBPs. You still get 4K at 60 Hertz, but your chroma sampling goes down to 4.2.0.
Okay, so for someone who isn't a video engineer, what does that drop from 4.4.4 to 4.2.0 actually look like on a screen?
Okay, for most video content, you might not even notice. But if you have something like sharp colored text on a contrasting background or really intense graphic,
You'd see it there.
you might see a little bit of fuzziness or color bleed around the edges. You're essentially sacrificing some color detail to gain that distance. The cost of distance is paid in color data.
And gets worse if you push it even further, right? To 98 feet.
Oh yeah, at that point you're down to just 1080p. The 4K signal is gone.
It's interesting. I noticed in the specs that for these longer runs, the cable itself has to get thicker. It uses a 24 AWG conductor.
It does. It needs that thicker wire just to carry enough power for the active components and maintain the signal integrity over that distance. It's a physically beefier cable.
But it still supports all the other standards you'd expect.
Oh, absolutely. You get full support for HDCP 2.2, HDR, EDDI, all the modern protocols.
Yeah.
And the audio is top-notch, 2 lossless, Dolby True HD, DTS HD, all of that.
So the bottom line for you, the listener, is this. An active copper cable is an amazing piece of tech. It simplifies installation, it boosts the signal.
But physics always wins in the end.
Right. For high-res signals over long distances, you have to be ready to accept a compromise, in this case, on color fidelity. That jump from 4.4.4 down to 4.2.0 is the price of admission.
And that leaves us with a really interesting question for the future, doesn't it? I mean, you see the incredible engineering effort it takes just to get a compressed 4K signal over 82 feet of copper. What's it going to take to finally eliminate these compromises for good? Is it just a matter of time before affordable fiber makes this whole conversation obsolete?